The morning of November 24, 1944, over Tokyo Bay, Flight Lieutenant Isamu Kashiide sat in the cockpit of his Kawasaki Ki-61 Hien fighter, climbing through 28,000 feet. Below him, the industrial suburbs of the capital sprawled in grey morning light. Above him, something was approaching that didn't belong in his sky. The Americans called it the B-29 Superfortress. Japanese intelligence had been tracking these aircraft since June, when the first raids struck from bases in China. Kashiide had read the reports: large bomber, high altitude capability, heavy payload, the usual American approach to strategic bombing, scaled up with their characteristic excess of resources and engineering. He'd fought B-24s over the Philippines 18 months earlier. He knew how American bombers died. His radio crackled with vectors from ground control, 30-plus bandits inbound from the Marianas, altitude 32,000 feet, heading north-northwest. The entire Tokyo fighter defense network was scrambling, 200 aircraft climbing to intercept. This would be the first major test of Japan's home island defenses against the new American bomber. Kashiide checked his ammunition count. 200 rounds for each of his twin 20mm cannons mounted in the nose, 200 rounds for each of his fuselage-mounted 12.7mm machine guns, enough to bring down 3, maybe 4 bombers if his gunnery was precise. He'd made ace in China, 7 confirmed kills against Chinese aircraft, 2 more over the Philippines against American P-38s. Bomber formation work was different, more methodical, but the principle remained the same. Close to optimum range, aim for the engines or cockpit, fire short controlled bursts, break away before the defensive gunners could track you effectively. American bombers had gun positions scattered across the fuselage. Waist guns, top turrets, ball, turrets on the belly, nose guns, tail guns. You learned their blind spots. You attacked from angles where their guns couldn't traverse fast enough to follow. You used speed and surprise. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. At 29,000 feet, Kashiide spotted them, a formation of silver bombers, 3 groups stacked in altitude, each group in a tight combat box. They looked enormous even at distance. Sunlight glinted off polished aluminum. The Americans didn't even bother with camouflage anymore. That told you something about their confidence, about their assessment of Japanese fighter capability. They flew in daylight, unpainted, certain that Japanese defenses couldn't stop them. Kashiide pushed his throttle forward, climbing toward the nearest formation. Around him, other Ki-61s and older Ki-43s were converging on the bombers. Some pilots would attack from the front, the classic head-on approach that gave the bombers' gunners the smallest target and the least time to fire. Others would come from above and behind, diving through the formation at high speed. Kashiide planned a tail approach. Come in slightly low, climb into firing position from the 6 o'clock, aim for the wing route where fuel tanks were located, kill the engines, watch the bomber fall away. He'd done this before. He knew what to expect. American bomber formations bristled with 50 caliber machine guns, but their firepower was dispersed. Individual gun positions had limited traverse and elevation. A skilled pilot could exploit those limitations. The tail gun position on a B-24, for instance, was exposed and vulnerable. The gunner sat in a cramped, cold position with restricted vision. If you approached from slightly below the direct 6 o'clock line, his guns couldn't depress enough to hit you until you were already in firing range. Then it became a question of who fired first, who fired more accurately. Kashiide armed his weapons. His fighter vibrated with the strain of high-altitude flight, the thin air reducing engine performance. The bomber formation grew larger in his windscreen. He could see individual aircraft now, could see the sunlight reflecting off plexiglass turrets. He selected his target, a bomber on the lower right edge of the formation, slightly separated from its neighbors. That one. He adjusted his approach angle, positioning himself for the tail attack that had worked so many times before. What Kashiide didn't know, what Japanese Fighter Command didn't yet understand, was that everything they believed about bomber defensive tactics had just become obsolete. To understand what happened next, you need to understand what Japanese fighter pilots had learned about attacking American bombers, and why those lessons were about to fail catastrophically. Since 1942, Japanese pilots had developed tactics specifically designed to destroy B-17 flying fortresses and B-24 Liberators. These tactics were based on systematic observation of American defensive gun positions, careful analysis of engagement ranges, and hard-won experience purchased with the lives of pilots who had learned the wrong lessons. The B-17 carried 13 50-caliber machine guns in various positions throughout the aircraft: twin guns in the tail, twin guns in the ball turret on the belly, twin guns in the top turret behind the cockpit, single guns in waist windows on each side of the fuselage, single guns in the nose, operated by the bombardier. It looked formidable on paper, nearly 7 tons of aircraft defended by 13 heavy machine guns, but Japanese fighter pilots, survivors of dozens of bomber interceptions, knew the reality was more complex. The gun positions were manually operated. Each gunner physically aimed his weapons, tracking targets through optical sights, correcting for aircraft motion and relative velocity. The guns had limited traverse arcs. The tail guns, for instance, could cover roughly a 90-degree cone behind the aircraft. The waist guns could fire to either side but had poor coverage directly behind. The ball turret couldn't fire straight down because the guns would hit the turret's own structure. Most importantly, the guns were not coordinated. The tail gunner couldn't see what the waist gunners were engaging. The top turret gunner had a different field of view from the ball turret gunner. Each position operated independently, defending its own sector. This created gaps. It created angles of approach where only 1 or 2 gun positions could engage an attacking fighter, where the bomber's defensive fire was weakest. Japanese fighter tactics evolved to exploit these weaknesses. Attack from ahead when possible, closing at a combined speed of over 500 miles per hour, giving the bomber's forward-firing guns perhaps 3 seconds to hit a target approaching nearly head-on. Attack from below, where only the ball turret could engage, and where that single gun position could be suppressed by multiple fighters attacking simultaneously. Attack from directly astern, accepting fire from the tail guns but minimizing exposure time by approaching at high speed, firing a concentrated burst into the wing root or tail section, then diving away before the bomber's other guns could traverse to engage. These tactics worked. Japanese pilots documented dozens of B-17 and B-24 kills over the Philippines, over Formosa, over the approaches to the home islands. The tactics were refined through experience, codified in training documents, taught to new pilots joining fighter units. By late 1944, the tactical doctrine for bomber interception was well established. The senior pilots, the survivors, knew how to kill American heavy bombers. What they didn't know was that Boeing and General Electric had spent 3 years solving the exact problems Japanese pilots were exploiting. The B-29 Superfortress wasn't just larger than previous American bombers, it was fundamentally different in concept, representing the first aircraft designed from the beginning as an integrated weapons system rather than an aircraft with guns attached. Boeing began preliminary design work in 1939, years before the United States entered the war. The Army Air Corps wanted a hemisphere defense bomber, an aircraft capable of striking targets thousands of miles from American shores. The specifications demanded pressurized crew compartments for high-altitude operations, heavy defensive armament, and range exceeding 5,000 miles. These requirements pushed the boundaries of existing aviation technology. The defensive armament problem was central to the entire design. Previous bombers carried individual gunners at separate stations throughout the aircraft. Each gunner operated his guns manually, aiming through optical sights, firing independently. This approach had serious limitations. Gunners in unpressurized positions like the waist or tail suffered from cold, hypoxia, and fatigue at high altitude. Manual gun operation was physically exhausting. Optical sights were difficult to use accurately while tracking fast-moving targets. Most critically, individual gun positions couldn't mass their fire effectively against a single threat. Boeing partnered with General Electric to develop a solution that had never been implemented on any production aircraft. Remote-controlled gun turrets. The concept was straightforward in principle, but extraordinarily complex in execution. 4 turrets would be mounted at strategic positions on the aircraft. Each turret would contain 2 50-caliber machine guns. The turrets would be controlled remotely by gunners sitting in pressurized compartments inside the fuselage, aiming through computing gunsights that automatically calculated deflection for target motion and ballistics. General Electric's engineering team, working in facilities in Bridgeport, Connecticut, and Schenectady, New York, spent 2 years developing the system. The technical challenges were substantial. The turrets had to rotate rapidly and smoothly, while tracking targets moving at high relative velocities. The control systems had to be precise, translating the gunner's sight movements into turret motion with minimal lag. The computing sites had to calculate bullet drop, target lead, and parallax correction in real time. All of this had to function reliably at 40,000 feet in temperatures 60 degrees below zero. The final system, designated the Central Fire Control System, was a marvel of wartime engineering. Each of 4 remote turrets could be controlled by any of several gunner stations. The top forward turret, located just behind the cockpit, and the top aft turret, located behind the wing, could both be operated by the gunner in the forward upper position or by the gunner in the aft upper position. The 2 lower turrets, mounted on the belly, could be controlled by the gunners in either upper position or by a dedicated lower gunner stationed amidships. This flexibility meant that damaged gunner stations could be bypassed, and that multiple gunners could concentrate fire on a single attacking fighter. The tail position was different. It carried 2 50-caliber machine guns and, on later production models, a 20mm cannon. These guns were manually controlled by a gunner sitting in a pressurized compartment in the tail cone, but they were backed up by the massed fire from the remote turrets if a fighter approached from directly astern. By the time the first B-29's reached operational units in 1944, each aircraft carried 10 50-caliber machine guns in the remote turrets, 2 more 50-caliber guns in the tail, and 1 20mm cannon in the tail. More importantly, these weapons were integrated into a coordinated defensive system that could bring multiple turrets to bear on a single threat. Japanese intelligence knew the B-29 existed. They had estimates of its size, speed, altitude capability, and bomb load. What they didn't fully understand, what their reconnaissance reports and early combat observations hadn't revealed, was the revolutionary nature of its defensive armament. They were about to learn. The men who would operate the B-29's defensive systems underwent training that was fundamentally different from gunners on earlier American bombers. These weren't just men learning to fire machine guns from aircraft. They were being trained to operate what was essentially the first airborne fire control computer system ever deployed in combat. Central Fire Control, gunnery school at Laredo Army Airfield in Texas, processed thousands of gunners between 1943 and 1945. The course lasted 6 weeks, far longer than the basic aerial gunnery course for B-17 or B-24 gunners. The first week focused entirely on the theory of the computing gunsight, teaching students how the system automatically calculated lead angles, bullet drop, and deflection. Students learned that the sight integrated inputs from the aircraft's airspeed indicator, altitude, and the gunner's tracking motion to solve ballistic equations in real time. The heart of the system was the B-3 computing sight. The gunner looked through an optical sight with a reticle, a circle of diamonds surrounding a central aiming point. To engage a target, the gunner placed the reticle on the target aircraft and tracked it smoothly. The sight measured the angular rate of movement and, combined with range estimation from the operator's adjustment of the reticle size, computed where the bullets would actually impact given their time of flight and the target's motion. This was revolutionary. On earlier bombers, gunners aimed by instinct and experience, leading targets by guessing how far ahead to fire. Experienced gunners developed intuitive understanding of deflection shooting, but it was difficult to learn and impossible to systematize. The computing sight made accurate deflection shooting possible for average gunners with moderate training. Week 2 introduced students to the physical turret controls. Each gunner station had a control column similar to an aircraft yoke. Pushing the column forward moved the turret down, pulling back moved it up, turning the column left or right rotated the turret in azimuth. The turrets responded instantly to control inputs, rotating at speeds up to 60 degrees per second, far faster than manual turrets on earlier bombers. Students practiced tracking moving targets projected on screens, learning the hand-eye coordination necessary to keep targets centered in their sights. Week 3 covered the central fire control system's flexibility. Students learned that they could switch between turrets without leaving their stations. The forward upper gunner could control either the forward upper turret or the forward lower turret by flipping a selector switch. If his position was damaged or he was wounded, the aft upper gunner could take control of both forward turrets. The system was designed with redundancy, ensuring that gun coverage could be maintained even after battle damage. Weeks 4 and 5 involved live firing exercises. Students flew in training aircraft, actual B-29's configured for gunnery practice, firing at towed targets. The targets were cloth sleeves, bright orange or red, towed behind other aircraft at distances of 1 to 2,000 feet. Students learned to estimate range by adjusting the reticle size until the target appeared to fill the circle, then tracking smoothly while firing short bursts. The 50 caliber Browning machine guns in each turret cycled at roughly 800 rounds per minute. A 1-second burst fired approximately 13 rounds per gun, 26 rounds total from a 2-gun turret. Instructors emphasized ammunition conservation. Each B-29 carried finite ammunition. The exact load varied by mission, but typical combat loading was 500 rounds per gun, 5,000 rounds total for the 10 guns in the remote turrets. Additional ammunition for the tail guns brought the total load to approximately 6,000 rounds. This sounded like abundant firepower until you calculated actual firing time. At 800 rounds per minute per gun, a single turret could exhaust its ammunition in less than 4 minutes of continuous fire. The final week covered emergency procedures and crew coordination. Students learned what to do if the electrical system failed, how to manually crank turrets to safe positions, how to clear gun jams remotely using clearing motors, how to communicate with the aircraft commander about ammunition status and engagement ranges. They learned that their primary mission wasn't to shoot down fighters. It was to keep fighters outside effective attack range, to force enemy pilots to break off before reaching optimum firing position, to survive long enough to deliver bombs on target. Graduates of the Central Fire Control Gunnery School received their aerial gunner wings and assignment to B-29 combat crews. They knew their equipment was the most advanced defensive system flying. They knew they had capabilities no other bomber crew possessed. What they didn't know yet was how effective those capabilities would prove against enemy fighters that had learned their trade-destroying bombers with simpler, less integrated defensive systems. Lieutenant Kashiide closed to within 800 meters of his target bomber, positioning himself slightly below and directly behind the massive aircraft. The bomber's size was stunning at this range. It dwarfed the B-24's he'd fought over the Philippines. The wingspan had to be at least 40 meters. The fuselage was deep and wide, with a prominent vertical stabilizer towering above the horizontal tail surfaces. He could see gun positions, a turret on top of the fuselage behind the wing, another turret further forward, near the cockpit. The tail appeared to have guns, though from his angle he couldn't see details. Standard American approach, multiple gun positions covering different sectors. He was below their direct line of fire, climbing slightly to bring his guns to bear on the wing route where fuel tanks would be located. At 600 meters, he began his firing run. His gunsight reticle centered on the bomber's port wing, just outboard of the inboard engine. At 400 meters, he'd open fire. Short burst from the cannons, longer burst from the machine guns. Aim for the fuel tanks, aim for the engine. Watch for the smoke that indicated hits, the flame that indicated fire, the wing that folded as structural members failed. At 500 meters, the bomber's turrets moved, not the slow, deliberate traverse of manual turrets tracking a target. Rapid, precise movement, snapping into position with mechanical speed impossible for hand-cranked guns. The top-aft turret rotated backward, depressing its guns downward. The top forward turret did the same, rotating to cover the rear quarter. Both turrets locked onto him simultaneously. Kashiide had perhaps 1 second to process this before both turrets opened fire. The combined muzzle flash from 450 caliber machine guns was brilliant, even in daylight. Tracer rounds, every fifth round in American ammunition belts, arced toward his aircraft in lines of fire that appeared solid, continuous streams rather than individual bullets. The rate of fire was incomprehensible. His experience told him that turrets fired in bursts, gunners squeezing triggers, weapons cycling through their ammunition at rates dictated by manual operation. These turrets fired as though controlled by machinery, sustained bursts with no human pause between trigger pulls. Because they were controlled by machinery. The gunners were inside the pressurized fuselage, warm and comfortable, aiming through computing sights that calculated deflection automatically, their fingers on electrical firing triggers that activated remote guns with no mechanical lag. Tracer rounds passed above Kashiide's canopy, so close he instinctively ducked. Others passed below his wing. The bomber's gunners were adjusting fire, walking their bullets onto his aircraft with corrections measured in fractions of degrees. He broke left hard, throwing his Key 61 into a diving turn that pulled nearly 5 times the force of gravity, trying to get out of the engagement envelope before the concentrated fire found him. More tracers followed his break. The turrets tracked smoothly through his evasive maneuver, remaining locked on target through motion that should have broken a manual. Gunner's aim. He saw impacts on his right wing, bright sparks where 50 caliber rounds struck aluminum skin. His aircraft shuddered. The control column jerked in his hands. He dove away, trading altitude for speed, putting distance between himself and the bomber that had just demonstrated firepower he didn't know existed. Around him, other Japanese fighters were discovering the same truth. A Key 43 attempting a head-on attack met coordinated fire from the forward turret and the upper forward guns. The fighter's engine exploded in a spray of coolant and metal fragments. The pilot, if he survived the initial impacts, had seconds to bail out before his aircraft entered an uncontrolled spin. He didn't make it out. The fighter, trailing smoke and flames, fell away toward Tokyo below. Another Key 61 tried the classic tail approach that Kashiide had attempted. The pilot positioned himself precisely, using tactics that had worked against B-24's. He closed to 300 meters before opening fire, his cannons and machine guns raking the bomber's tail section. Return fire from the tail guns was immediate and accurate. The tail gunner, sitting in his pressurized compartment with excellent visibility and manually controlled weapons, had clear sight picture and stable firing platform. His 250 caliber guns fired in synchronized bursts. The Key 61's engine took multiple hits. Coolant poured from ruptured lines. The pilot tried to break away, but his engine seized, the propeller windmilling uselessly. The fighter fell behind the bomber formation, losing altitude, the pilot wrestling with controls that no longer responded properly. He managed to crash land in a rice paddy north of the city. He survived with injuries. His aircraft was destroyed. His understanding of bomber defensive tactics was shattered. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The November 24th raid lasted approximately 2 hours from first fighter contact to the last B-29 clearing Japanese airspace. Japanese fighter units threw 200 aircraft against the bomber formation. They shot down 2 B-29's through combined attacks involving multiple fighters hitting individual bombers simultaneously. They damaged perhaps a dozen more, forcing some to abort the mission and return to bases in the Marianas with battle damage. The Americans shot down 17 Japanese fighters with defensive fire alone, not with fighter escort, not with anti-aircraft artillery, with the bomber's own guns. Another 23 Japanese fighters were damaged severely enough that they crashed on landing or were written off as combat losses. Total Japanese fighter losses exceeded 40 aircraft from a force of 200, 20% losses in a single engagement. The mathematics were brutal. At this loss rate, Japan's fighter defense network would be exhausted within months. Pilot losses were even more catastrophic than aircraft losses because trained pilots couldn't be replaced as quickly as factories could produce new fighters. The pilots shot down on November 24th represented thousands of hours of training, years of combat experience, institutional knowledge that died with them in the wreckage of their aircraft. Flight Lieutenant Kashiide landed at his base with his right wing damaged, 63 holes from 50 caliber fire counted by maintenance crews. His engine had sustained minor damage, but remained functional. He'd fired all 400 rounds from his 20mm cannons and most of his machine gun ammunition. He'd scored no confirmed hits on any bomber. His combat report, submitted that evening, was unusually detailed. He described the turret movement as unlike any bomber he'd previously engaged. He noted that defensive fire began at ranges where manual gunners typically couldn't track effectively. He documented that the turrets appeared to be coordinated, multiple turrets engaging a single fighter simultaneously. He reported that tracer fire appeared continuous rather than intermittent, suggesting either very high rates of fire or very large ammunition loads. His conclusions were measured but clear. Standard tail approach tactics were ineffective against this bomber type. The defensive fire was too accurate, too heavy, too well coordinated. Alternative attack methods needed to be developed urgently before the bombers returned, because they would return. Everyone knew that. The Americans had captured the Marianas. They had built bomber bases on Saipan, Tinian, and Guam. They had B-29's by the hundreds. Tokyo was now within range of strategic bombing, and the first raid had demonstrated that Japanese fighter defenses were inadequate. Other combat reports from November 24th echoed Kashiide's observations. Pilots from multiple units described similar experiences: unusually accurate defensive fire, rapid turret movement, coordinated engagement from multiple gun positions. Several reports specifically noted that tail approaches, previously considered among the safer attack vectors against American bombers, were particularly deadly against the B-29. Fighter Command compiled these reports and issued preliminary tactical guidance within 48 hours. The directive was distributed to all fighter units assigned to home defense. The language was bureaucratic and formal, but the content was stark. Avoid tail approaches against B-29 bomber types unless no other attack vector is available. The tailgun position on this aircraft type demonstrates significantly improved accuracy and rate of fire compared to previous American bomber types. Multiple aircraft losses during the November 24th engagement resulted from fighters attempting tail approaches. The directive went further. It recommended attacking from above and ahead when possible, diving through the formation at high speed to minimize exposure time. It suggested coordinating attacks with multiple fighters hitting the same target simultaneously, from different angles to overwhelm the defensive fire control system. It emphasized the importance of breaking off attacks before closing inside 500 meters, the range where defensive fire became most accurate and deadly. What the directive couldn't say explicitly, but what every pilot who read it understood, was that the tactical advantage Japanese fighters had enjoyed over American bombers had evaporated. The Americans had engineered a solution to a tactical problem, and that solution was effective enough to shift the balance of air combat over Japan. The bombers were no longer vulnerable targets that skilled pilots could attack with reasonable expectation of survival. They were defended fortresses that killed fighters faster than fighters could kill them. The B-29's returned to Tokyo on November 27th, just 3 days after the first raid. Then again on November 29th, then December 3, then December 13. The pattern established in late 1944 would continue with increasing intensity through the spring and summer of 1945. By March, raids involved 300 or more bombers. By May, the Americans were conducting multiple raids per week, sometimes multiple raids in a single day. Japanese Fighter Command tried everything. They developed new tactics based on hard lessons from each engagement. They issued directives emphasizing coordinated attacks. They trained pilots in specific maneuvers designed to exploit whatever weaknesses the B-29's defensive system might have. They experimented with different approach angles, different speeds, different altitudes. Nothing fundamentally changed the mathematics of attrition. The recommended attack profile evolved into what survived pilots called the overhead pass. Fighters would climb above the bomber formation, sometimes to 35 or even 40,000 feet, altitude where both aircraft and pilots struggled to function. From this position, they'd roll inverted and dive nearly vertical through the formation, building speed to over 400 miles per hour, firing as they passed through, and then continuing the dive to escape altitude before climbing to repeat the attack. This tactic minimized exposure time. A fighter diving vertically through a bomber formation spent perhaps 3 seconds in effective gun range. The B-29's turrets, as advanced as they were, couldn't track fast enough to bring concentrated fire on a target moving that rapidly through their engagement envelope. The attacking pilot had only a brief moment to aim and fire, but if his gunnery was accurate, he could damage or destroy a bomber before defensive fire became lethal. The problem was that this tactic was extraordinarily difficult to execute. Hitting a target while diving nearly vertical at 400 miles per hour required exceptional piloting skill and precise gunnery. Most pilots missed. The successful attacks, the ones that resulted in bomber kills, came from the most experienced fighter pilots, men who had been flying combat missions since 1941 or 42, men whose instinctive understanding of deflection, shooting, and aircraft handling made them capable of shots that average pilots couldn't attempt. These veteran pilots were irreplaceable. When they died, and they did die because even the overhead pass exposed fighters to defensive fire during the critical seconds of the attack, they took with them knowledge and skill that newer pilots simply didn't have. By early 1945, the average experience level of Japanese fighter pilots had decreased dramatically. The veterans were dead or wounded or assigned to training duties, trying desperately to teach new pilots skills that took years to develop. The new pilots, rushed through abbreviated training programs with limited flight hours and almost no combat experience, faced B-29's, defended by systems they couldn't defeat, with tactics they couldn't properly execute. Flight Lieutenant Kashiide survived the war. His combat record shows 37 defensive sorties against B-29 raids between November 1944 and August 1945. He claimed 3 bomber kills, 2 confirmed by squadron records, 1 unconfirmed. 3 kills from 37 sorties represented a ratio that would have been considered poor earlier in the war, when he'd claimed 9 kills in approximately 20 sorties over China and the Philippines. But against the B-29, 3 confirmed kills ranked him among the more successful home defense pilots. His aircraft was shot down twice. The first time, in January 1945, defensive fire from a damaged B-29 he was attempting to finish off struck his engine and cockpit. He bailed out at 12,000 feet and landed in a forested area north of Tokyo with minor injuries. His second shoot-down came in April, when coordinated fire from 2 B-29 turrets hit his fighter during an overhead pass. He managed to crash land with the aircraft on fire, sustaining burns to his hands and face that required hospitalization for 3 weeks. After the war, during interviews with American military historians, Kashiide was asked about his experiences fighting B-29's. His answers were technical and measured. He described the defensive system as the most effective he'd encountered. He noted that the coordinated turret fire made traditional attack approaches suicidal. He acknowledged that by mid-1945, Japanese fighter pilots understood they had almost no chance of stopping the bombing campaign. The best they could hope for was to shoot down enough bombers to make the raids expensive for the Third Americans, to force them to factor defensive losses into their strategic calculations. When asked if he believed Japan could have won the air war over the home islands, Kashiide's answer was direct: no, not with the equipment we had, not against their defensive systems. We were fighting with aircraft designed in the 1930s against technology from the 1940s. The Americans had solved the bomber defense problem. We never solved the problem of how to attack bombers that could defend themselves that effectively. The B-29's defensive armament system represented more than just technological advancement. It represented the application of American industrial and engineering capability to a specific tactical problem, and the solution's effectiveness demonstrated principles that extended far beyond aerial combat. Boeing and General Electric didn't develop the central fire control system in isolation. The program involved dozens of subcontractors producing specialized components. Sperry Gyroscope Company manufactured the computing sights, drawing on their experience with bomb sights and fire control systems for naval vessels. Westinghouse produced electrical motors for turret traverse. Smaller companies manufactured the complex mechanical linkages, the amplifiers that converted gunner control inputs into turret movement, the ammunition feed systems that delivered 50 caliber rounds to guns firing at sustained rates. The entire system required precision manufacturing at scales that would have been impossible earlier in the century. Each computing site contained hundreds of machined parts, gears and cams and optical elements manufactured to tolerances measured in thousandths of an inch. The turrets themselves were mechanical marvels, capable of rotating smoothly and accurately while subjected to aerodynamic forces at high altitude and temperature extremes, ranging from 60 degrees below zero to temperatures exceeding 100 degrees inside sun-heated fuselage spaces. Production of these systems required training workers in skills that didn't exist before the war. General Electric established specialized training programs for assemblers and quality control inspectors. Workers learned to read complex engineering drawings, to test electrical circuits with specialized equipment, to verify that mechanical assemblies met specifications. The learning curve was steep, but American industrial capacity, built on decades of mass production experience in automotive and appliance manufacturing, adapted quickly. By mid-1944, production rates exceeded 100 complete central fire control systems per month. Each system represented approximately 3,000 man-hours of labor, from component machining through final assembly and testing. The systems were shipped to Boeing plants in Wichita, Kansas, and Renton, Washington, where they were installed in B-29 airframes on assembly lines that produced finished bombers at rates approaching 100 aircraft per month at peak production. Japan had nothing comparable. Japanese industry in 1944 was struggling to maintain production of basic military equipment. Factories lacked raw materials as American submarines interdicted shipping from Southeast Asia. They lacked skilled workers as men were drafted for military service. They lacked the machine tools necessary for precision manufacturing, tools that had been imported from the United States and Europe before the war and couldn't be replaced once supplies were cut off. Japanese engineers understood the principles of remote-controlled turrets and computing gunsights. They had examined captured American equipment. They had designed prototype systems that incorporated similar concepts, but moving from prototype to production required industrial infrastructure that Japan simply didn't have. The gap between knowing what needed to be built and being able to build it in meaningful quantities was insurmountable. This pattern repeated across virtually every category of military technology. The B-29 itself represented capabilities Japan couldn't match. Its pressurized cabin, its 4 Wright R3350 engines, each producing 2,200 horsepower, its remote-controlled turrets, its sophisticated navigation and bombing systems, all required industrial capabilities and resources that Japan lacked. The Americans could produce these aircraft by the hundreds. Japan couldn't produce equivalent aircraft at all. The bombing campaign's statistics told the story with brutal clarity. Between November 1944 and August 1945, B-29's flew approximately 33,000 individual sorties against Japanese targets. They dropped approximately 170,000 tons of bombs. They destroyed or damaged hundreds of square miles of urban and industrial areas. Tokyo, Osaka, Nagoya, Kobe, Yokohama, all major Japanese cities experienced devastating incendiary raids that killed hundreds of thousands of civilians and destroyed the industrial infrastructure necessary to sustain military operations. Japanese fighter defenses shot down approximately 500 B-29's during this period, roughly 1.5% of sorties flown. This loss rate was sustainable for the Americans. They produced more B-29's each month than they lost in combat. Crew losses could be replaced through training programs that graduated thousands of new airmen each month. The strategic bombing campaign continued with increasing intensity regardless of defensive efforts. For Japan, the defensive campaign was unsustainable. Fighter losses exceeded production capacity. Pilot losses couldn't be replaced with adequately trained replacements. Fuel shortages grounded aircraft even when they were available. By summer 1945, Japanese air defenses had effectively collapsed. B-29's flew missions with minimal or no fighter opposition. Their sophisticated defensive systems no longer needed because the enemy couldn't mount effective attacks. When the war ended in August 1945, American technical intelligence teams examined Japanese aircraft and interviewed surviving pilots and engineers. They wanted to understand what the Japanese had learned, what their tactical evolution had been, what their assessment of American equipment and tactics was. The interviews with fighter pilots who had engaged B-29's provided consistent testimony. The defensive armament system was the decisive factor, not the only factor, but the primary reason why Japanese fighters couldn't stop the bombing campaign. Previous American bombers, the B-17 and B-24, had been vulnerable to skilled fighter attack. Losses were significant enough that strategic bombing campaigns in Europe required fighter escort deep into German territory. The B-29 didn't require escort over Japan. Its defensive systems were sufficient to maintain acceptable loss rates even against concentrated fighter opposition. Japanese pilots uniformly described the tail approach as suicidal. The combination of the tail gunner's manually controlled weapons and the remote turrets that could engage targets approaching from astern created overlapping fields of fire that no single fighter could survive. The directive to avoid tail approaches, issued after the first raids in November 1944, remained in effect throughout the war. Pilots who violated it, whether through tactical error or desperation, died. The technical intelligence teams examined recovered B-29 wreckage, studying damage patterns to understand how defensive fire affected attacking fighters. They interviewed surviving B-29 gunners, asking about engagement ranges, ammunition expenditure, and kill claims. The data compiled from these sources painted a comprehensive picture of how the central fire control system performed in combat. Average engagement range was approximately 600 to 800 meters. Gunners opened fire at these ranges, tracking targets as they closed, maintaining fire until the attacking fighter broke off or was destroyed. Ammunition expenditure averaged approximately 50 to 80 rounds per gun per engagement, suggesting that gunners fired controlled bursts rather than continuous streams. This discipline meant that ammunition lasted through multiple engagements. B-29's returning from missions typically had 40 to 60% of their defensive ammunition remaining. Kill claims were difficult to verify precisely, but statistical analysis suggested that B-29 defensive fire accounted for approximately 60% of Japanese fighter losses during raids where fighters engaged the bombers. The remaining 40% of losses came from other causes: operational accidents, damage sustained during attacks that resulted in crashes after fighters broke off, or kills by escorting fighters during periods when escort was available. The B-29's defensive system was the primary killer of Japanese fighters over the home islands during the strategic bombing campaign. The lesson that emerged from this analysis was fundamental: technology matters, industrial capacity matters. The ability to field advanced systems in meaningful quantities determines outcomes in modern warfare. Courage, training, and tactical skill remain important, but they cannot overcome vast disparities in equipment capability. Japanese fighter pilots were skilled and brave and determined. Their aircraft were obsolescent. Their tactics were developed for different opponents. Their defensive systems couldn't coordinate fire effectively. They lost not because they fought poorly, but because they fought with inadequate tools against an enemy that had solved technical problems they couldn't address. Flight Lieutenant Kashiide, in his post-war interviews, returned repeatedly to this theme. He didn't blame Japanese pilots or tactics or training. He blamed the industrial gap, the inability of Japanese factories to produce equipment comparable to what the Americans fielded. He noted that by 1945, Japanese pilots knew they were flying missions they couldn't survive, attacking bombers they couldn't defeat, trying to defend cities they couldn't save. They flew anyway because orders required it, because duty demanded it, because stopping would have been abandonment. The B-29's tail guns, and the remote turrets that supported them, represented the future of aerial warfare. Post-war bomber designs incorporated and expanded on these concepts. The Boeing B-50, essentially an upgraded B-29, retained the central fire control system. The Convair B-36, the massive strategic bomber developed immediately after the war, carried an even more sophisticated defensive system with additional turrets and improved fire control computing. Jet bombers of the 1950s and 60s continued the evolution, culminating in systems that automatically tracked and engaged threats without human gunners. The era of manned defensive gun positions on bombers ended eventually, replaced by electronic countermeasures and missile defense systems, but the principle established by the B-29's central fire control system remained. Integrate defensive weapons into coordinated systems. Use technology to multiply the effectiveness of human operators. Engineer solutions to tactical problems. These concepts, proven effective over Tokyo and Osaka and Nagoya, became foundational principles of military aviation. For the Japanese fighter pilots who radioed warnings to avoid tail approaches, who learned through bitter experience that American engineering had outpaced their tactical understanding, the lesson was simpler and more personal. They'd been sent to fight a war their equipment couldn't win, against opponents whose industrial capacity and technological sophistication exceeded anything their training had prepared them for. The directive to avoid the tail approach wasn't just tactical guidance. It was an acknowledgement of obsolescence, an admission that the war they'd been trained to fight was not the war they were actually fighting. That realization, purchased with hundreds of fighters and thousands of trained pilots lost in the skies over Japan, echoed in the decades after the war ended. It became a case study in military academies, an example taught to officers learning about the relationship between technology and tactics. It appeared in engineering texts discussing fire control systems and defensive armament design. It informed strategic thinking about industrial capacity and weapons development. The tail guns of the B-29 and the coordinated turret system that supported them became legendary not because they were the most powerful weapons of World War II, but because they represented a solution so effective that an entire enemy air force had to fundamentally change how it fought and still couldn't win. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.